This is the second video of the series of driving a Fusion 360 assembly from a gaming controller. And this video I want to show you a couple of tricks I've used to help the assembly work better from the gaming controller. The first one is the fact that the top of the robot, this grabber at the top, I really need to keep parallel to the boxes as I pick them up, move them around and so on. And unfortunately in Fusion, unlike Inventor, we don't have a constraints option in the assembly modeler. We only have joints, and we haven't got anything like an angle constraint to use. But that's not a problem in Fusion. What we do is we create an extra solid as a helper to enable us to create the joints between this component and another component in make them parallel to each other. So if I right click on the assembly and create a new component, I'll just call this helper, and create a sketch on the base plane. Just draw a circle and we'll extrude that. Okay, so there's our body or component that's been created. If I go back to the assembly, what I can do now is add joints between this helper component and the various components on my assembly to enable me to keep the bottom of this grabber parallel to the ground plane. So if we add a joint, the first joint I want to add is planar, and this is going to be between the bottom of the grabber and the top of the helper solid. Okay, and finally the other joint that we need to add is between the axis of the helper solid component and possibly this grounded disc here would help. So if we go to joints again, this time we'll add a slider joint and add this between the cylinder of the helper component and the cylinder at the base here. And now let's just turn on one of these joints so the assembly works properly. So now as we move this arm of the robot up and down, you can see what's happening. That helper solid is now acting according to the joints I've added, and it enables me to move this robot around, but the bottom of the grabber is always parallel to the base plane. Okay, so we can just turn off the visibility of the helper, and that's the robot working as I require it. You can use this technique in other assemblies, obviously. It might be useful in the future for you. The other thing we've got here is the fact that as I grab these boxes, I don't really want the robot to move through them. So what we can do in this is use something called contact sets. And with contact sets, what we do here is we add components that we actually want to make sure don't interfere with each other as they move around. So we've got the grabber on the robot and the three boxes. That's what I want to check for contact between. So if I click on OK on that, what happens now, as I move this robot arm down, you can see as I get to the box, let's move this box back, it slid off, which is a bit of a byproduct with using contact sets. But as I move this down, you can see it touches, it will not move past this box. If I ground this box, there we are. as I move the robot down, look, you see it won't go any further than the top of that box. So by using contact sets, it means that when we move the robot around, it's going to look more realistic. The components are not going to interfere with each other. Be careful with contact sets, it's quite CPU intensive, so make sure you only select the components that you require. So that's the assembly setup for driving from my gaming controller. The next video I'll go through how we write the software to interface the controller with this assembly, and how we actually drive this, the joints in this assembly. So look out for the third video in the series, and thank you very much.